In today's lesson, we're going to talk about how many solutions. So we've already talked about all solutions, no solutions, and then we talked about the one solution just by solving equations and figuring out the value of that variable that's going to make both sides true. Well, today we're going to dig a little bit deeper in that. And we're going to be looking at several different equations, making use of structure to make sure that we understand how to determine how many solutions. In today's lesson, we're looking at how many solutions, and this is not the first time that we've talked about number of solutions, but we're going to dig a little bit deeper. So let's solve equations with different number of solutions. We're going to solve equations with different number of solutions today. We're going to do some matching of solutions starting off with our warm-up. We're going to be matching solutions, okay? So we're going to be filling in the blank here. And based on what we fill in the blank with, we're going to determine how many solutions we will have. So consider this unfinished equation. Match the expressions with the number of solutions the equation would have with that expression. So I want you to take a couple of moments to look over 8.1 on page 55 and fill in the blank and then determine how many solutions you will have. So before we get started looking at our expressions, I want to go ahead and simplify the expression on the left side of our equation. So what do I mean? I want to go ahead and distribute and then combine my like terms. So 12 times x I know is 12x. 12 times negative 3 is negative 36. And then I'm going to bring down my 18. Then I'm going to combine my like terms, which are negative 36 and positive 18. So that's going to leave me with 12x minus 18. Okay, so this is what we're looking at and going to be comparing each of these expressions to. Okay, so if I did that with the left side, then let's see what we can do with the right side to compare them. It's going to make it easier for us to compare. So I'm going to look at the right side of my equation, and I'm going to start by distributing. So for the first one, I'll have 12x minus 18. Well, we notice right off the bat that this is the exact same expression that we had on the left side. So when we have the same expression on both sides of the equal sign, we know that this is an all solutions situation. Okay. Now let's look at B. For B, again, we're going to go ahead and distribute. When we distribute, we now have 12x minus 12. Well, 12x minus 12, our number of x's are the same because we have 12x on the left and 12x's on the right. However, that number that we're subtracting is different. Now, we talked about this in a previous lesson. When the variable term is the same, or the coefficient of x is the same, but we're adding or subtracting two different numbers, we're going to wind up in a no solutions situation. Okay, let's take a look at C. Now, obviously, we only have one option left, but let's just look and see what we got here. So I'm going to distribute. I got 8x minus 12. Well, right off the bat, we notice that our variable term, our coefficient of x, or our number of x's, is different on the right, in this case, than on the left. So in this case, we will have one solution. And we're going to keep looking at these different structures to see if we can determine the number of solutions. So let's keep it going. So again, we're making use of structure today. So here we're presented with a set of equations, and what we're going to do, and I am on page 56, what we're going to do is determine whether it has no solutions, exactly one solution, or is it true for all values of x, which means infinitely many solutions. If an equation has only one solution, we're going to solve it. Okay, so again, I am on page 56. So let's look at these and see if we can make sense of them, because we only have to solve one. We only need to solve the one that has one solution. So we're not going to waste our time trying to solve all of them. So let's see if we can make use of the structure, meaning what does it look like? So I am going to go ahead and distribute in equation B so I can have a simplified version of my expression and see what we're working with. Okay, so now I'm going to have 6x plus 8 is equal to 6x plus 8. Well, again, we know when we have the same expression on both sides, what does that mean? All solutions work. Okay, so all values of x will make this equation true. Now, let's look at A. In A, our x term, or our number of x's on either side, are not the same. Okay, they're not the same. Well, when they're not the same, this is what we've been dealing with since we've started this unit. This is a one solution situation. So we know that's the one that we're going to have to solve. When we look at C, I want you to notice that we have the same number of x's on both sides, but we are adding a different number to both of those terms. Okay, so that 8 and the 13, they're called constant terms. Because we are adding different constant terms, this is no solution. This is a no solution situation. So what I want us to do now is I want us to actually solve the one that we said had one solution. So let's do that. I'm going to start by combining my x terms. So I'm going to subtract 6x's from both sides. When I subtract from the left, I'm left with 0 x's, and I have 8, 1x, and 13. Then I'm going to combine my constant terms by subtracting 13 from both sides, and I am left with 0 constant terms on the right, 1x, and -5 on the left. So x is equal to -5. Now, how do we check our solution? We check our solution by substituting. Okay, so I could substitute in 6 times -5 and add 8 to that. And that should give me the same thing as 7 times -5 when I add 13 to that. So what is 6 times -5? That is -30. -30 plus 8 is -22. 7 times -5 is -35. -35 plus 13 is also -22. So we see we have a correct or true statement. Therefore, our solution is correct. Let's look at number 2. Let's take a look at number 2. So again, we are looking at whether or not these equations have no solution, one solution, or infinitely many. Remember that if it has one solution, we are going to solve it. So I'm going to start off by distributing. I'm going to be simplifying so I can see exactly what it is that I'm working with. So 1/4 of 12 is 3. And 1/4 of -4x is x. So with A, we see that we have the exact same expression on both sides. So that's going to be an all values or infinitely many solutions situation. For B, we see that we do not have the same number of x terms. On one side, we have a positive 1x, and the other side, we have a negative 1x. So this is going to be the one with one solution. Let's look at the last one. We have the same number of x terms on both sides, but we are adding 2 different numbers. So this is no solution. So now what we're going to do is we're going to solve the one that we said has one solution. So we're going to let's go ahead and start by combining our x terms. So I'm going to add x to both sides. So that's going to give me 2x's minus 3 is equal to 3. Then I'm going to combine my constant terms. So now I have 2x's is equal to 6. Well, I don't want to know about 2x's. I want to know about 1x. So I'm going to divide that by 2, and 1x is equal to 3. So how do I know if that is correct? I'll say 3 minus 3 is equal to 3 minus 3. Well, does 0 equal 0? Yes, it does. Therefore, our solution is correct. Let's look at the next set of equations. So here, we can go ahead and combine our like terms on the left side. So again, we can simplify and know exactly what it is that we are looking at. So for A, I know I have -8x plus 2, and that's equal to -8x plus 2. So already I see this is all values are infinitely many solutions. For B, I'm going to do the same thing. So I have -8x minus 4 is equal to -8x plus 2. Well, I got the same number of x's, but we're adding different constants. Therefore, that is no solution. The last one, I'm going to go ahead again and combine those x terms. So I got negative 9x minus 2 is equal to negative 8x plus 2. We got different number of x terms, so I have one solution. So this is the one that I am going to be solving. So let's go ahead and get into it. So again, I'm going to combine those x terms. And I'm going to keep combining, so I'm going to add 9 to both sides. So that's going to give me 0 x terms on the left is equal to 1 x term on the right plus 2. Then I'm going to subtract 2 from both sides, and I get x is equal to negative 4. Now remember, we can check our solution to make sure that we're right. And it doesn't matter which of these equations that I use, right? Because all of them are equal, because I got one from the other by doing the same move. So I'm just going to use the second one. Not because that's the easy one, but just because I'm going to show you that we can use any of them. So I have a negative 9 times negative 4, which is 36 minus 2. Then I have a negative 8 times negative 4, which is 32 plus 2. 36 minus 2 is 34. And 32 plus 2 is also 34. So guess what we have? We have a true statement. Therefore, our solution is correct. Let's look at the next one. So another set of equations. So you already know how I'm going to start. I want to simplify. I want to see exactly what I'm working with. So I'm going to go ahead and distribute. So I have 8x minus 8 plus 2 is equal to 4x minus 8. Okay. Then for the next one, I have 4x plus 4x minus 6 is equal to 8x minus 8. For the last one, I have 4x plus 4x minus 6 is equal to 8x minus 8 plus 2. So now, although I distributed, there are still ways for me to continue to simplify. Okay, so for the first one, I would have 8x minus 6 is equal to 4x minus 8. Well, we have two different numbers of x terms on both sides. So what does that mean? That we have a one solution situation. I'm just going to put a 1 this time for space. For the next one, we have 8x minus 6 is equal to 8x minus 8. Same number of x terms on both sides, but we're subtracting two different numbers. So no solution. NS for no solutions. With that last one, we have 8x minus 6 is equal to 8x minus 6. Well, we have the same expression on both sides, so that means all values of x would make this one true, or infinitely many solutions. So you already know which one we got to solve. We got to solve equation A. So I'm going to go ahead again and distribute. So I have 8x minus 8 plus 2 on the left and 4x minus 8 on the right. I'm going to continue to combine my like terms. 8x minus 6 is equal to 4x minus 8. Going to keep working by subtracting 4 x's from the right and left, which is going to leave me with 4 x's on the left, 0 x's on the right. Continuing to combine. So I have 4 x's is equal to negative 2. Divide both sides by 4, and I get x is equal to negative 1/2. So that is my solution, but as always, I want to check it to make sure that I am correct. So I'm going to substitute negative 1/2 in here. So I have 4 times negative 1/2. Remember I told you multiplying a fraction times a whole number in this way. Like if I have 4 times 1/2, that is the same thing as saying what is half of 4, right? Well, I know that half of 4 is 2. So the negative 1/2 of 4 would be the opposite of positive 2. It would be negative 2, right? So that's negative 2 minus 6. Now negative 2 minus 6 is negative 8. So because I got the same thing on both sides, that lets me know that my solution is correct. All right, I think we have one more. So let's look at our equations and determine which one we're going to have to solve for. So I want to go ahead and do some simplifying here so I can see exactly what I'm working with on both sides of the equation. So I'm going to do some distributing. So for the first one, I'm going to have x minus 6 plus 9x is equal to 10x plus 6. For the second one, same thing. We're going to have x minus 6 plus, oops, not plus. That's why we got to pay attention there. So minus 9x is equal to 10x minus 6. Same thing for the last one. I got x minus 6 plus 9x is equal to 10x's minus 6. Okay, so whenever I look at the first one, I notice that I have the same number of x's on both sides. So on the left, I have 10x's. On the right, I have 10x's. The difference is I'm subtracting 6 on one side and adding 6 on the other. So if I have the same number of x's, right? The same coefficient of x, but I'm adding or subtracting a different number, this is going to be a no solutions situation, okay? Let's look at B. B, I do not have the same number of x's on both sides because on the left, I have a negative 8x's and on the right, I have 10x's. So that means this is a one solution situation. So that's the one we're going to have to solve. For the last one, I have the same number of x's on both sides, and I have the same constant term on both sides. So this would be an all values or infinitely many solution situation. So let's go ahead and solve the one that we said had one solution. So again, I am just going to distribute. Okay. So I distribute or distributed. Now I'm going to combine my like terms. I'm going to keep combining my like terms. So I'm going to add 10x to both sides. So this is going to give me 2x minus 6 is equal to negative 6. I am then going to add 6 to both sides. And I get 2x is equal to 0. So the only number that I could multiply times 2 to give me 0 is 0. So I know x is 0. So let's go ahead and check it. Okay, so remember, I can use any equation, any of these equations. Why? Because I did the same move on both sides as I move from one line to the next, which means they're all equivalent and all have the same solution. So 2 times 0 minus 6 equals negative 6. Well, 2 times 0 is 0. So that leaves me with negative 6 on the left and negative 6 on the right. True statement. So we're good. So let's do some consolidation. What did you notice about equations that had one solution? If they had one solution, what do we know that was true? Well, one solution, there were what? There were different number of x's on both sides. There were a different number of x's on both sides. Will it always be x's though? Nope, it won't always be x's. It just means that whatever the coefficient of x is, it is not the same on both sides. So let's look at an example real quick. Let's say I have 6x plus 5 is equal to 3x minus 4. So on the left, I have 6 x's, and on the right, I have 3 x's. This is what we mean when we say different number of x's. So in this case, I could solve this equation and get a solution, okay? In this case, I could solve it and get a solution. Now, what about in the case where there was no solution? Okay, so I'm going to leave them all on the screen so we can kind of look at it together. When there was no solution, we had the same number of x's on both sides, and we were adding a different number, adding or subtracting, and different constant terms. So let's look at an example. So we'll use a similar example. Let's say I have 6x plus 5 is equal to 6x minus 4. So in this case, we have the same number of x terms, but our constant term, that number by itself without a variable, they're different, okay? So in this case, it's going to be a no solution. So let's look at why it would be no solution. So if I have 6x plus 5 is equal to 6x minus 4, well, when I combine my like terms, so let's say I add 4 to both sides. So now I have 6x plus 9 is equal to 6x. And I continue to combine my like terms because remember, the point is to get your variable on one side and what it equals on the other. Well, now I have 9 is equal to 0, which is not true. 9 is never equal to 0, okay? So when we have the same number of our variable, same coefficient on both sides of the equation, and different constant terms, this is going to be a no solution situation, okay? So let's look at that last one. Infinitely many solutions. What did we notice in this case? When there were infinitely many solutions, we had the same expression on both sides, okay? So for this one, we had the same expression on both sides. So what do I mean? 6x plus 5 is equal to 6x plus 5. Same exact expression. So it doesn't matter what x is. It doesn't matter what x is. I'm going to always be adding 5 to the product of that number and 6. So what does that look like? Let's say x was 1. That would be 6 times 1 plus 5 on both sides. Well, 6 times 1 is 6. And 6 plus 5 is what? 11. And 11 is going to always equal 11. Every day, all day. So again, today's goal was for us to look at different equations and to be able to determine the number of solutions. And we only solved one equation out of the 3 that we were given, right? We looked at the structure. We looked at what that equation had in it. We looked at the coefficients. We looked at the constant terms, and that helped us determine which of them had no solutions, one solution, or infinitely many solutions. So we've reached the end of our lesson. If you have any questions, please let me know by posting on the discussion board. Your notes are in Canvas. Please move forward to the cool down.